All right, well, we're going to continue on with Chapter 6 from the midpoint now. So we're going to focus on inequalities, which this is Lesson 7. And today all you're going to have to really worry about is addition and subtraction. Lesson 8 will deal with multiplication and division, and it has its own kind of unique things with it. But I often refer to inequalities as kind of the cousin of equations because they're going to look pretty much similar. When we get an answer to an equation, our answer might be something like x equals 3, right? We'd also have a problem up here, but that was our solution. And all that's going to be different today is that we're going to replace our equal sign with a greater than sign, or it could perhaps be a less than sign. And why this is significant, compare that to x equals 3. If that's the case, then x only has one value, right? X has to be 3. Can't be more, can't be less, has to be exactly that. What inequalities allow us to see is that the value of x is not limited to 3. It is, in this case, at least 3, right? X is greater than 3. So x could have a value of 3.1. It could have a value of 4. It could have a value of 10. It could have any value that is over 3. And so that's why inequalities can kind of be very helpful, because sometimes we're not looking for just one value. We're looking for any value. If you've ever asked a teacher, you know, what do I need to make in order to get an A? You're essentially saying, like, what is the minimum score I need to make to raise my grade to that? So what is X, knowing that you want, a certain grade, a certain percentage over here? And that's one way of looking at it. Or to get a driver's license, you have to be 16 years of age. So if we wanted to write that as an inequality, we could take out the 3 and we could put in 16, and this says that your age needs to be at least 16 years of age in order to have a driver's license. It could be more, it could be a lot more, but it's got to be at least 16. So that's kind of why we use inequalities. Now on this next slide here, there are several things that you need to fill in on your notes because I left them out on the sheet. So you need to fill in the words exactly and same. And this should make you feel pretty good here because we're going to solve the inequalities exactly the same as equations. We're going to do inverse operations. We're going to use Mrs. Green line to divide the problem into 2 parts. So it's all going to feel very similar there. Really what's going to be different is graphing. So let's go through and just fill these blanks in, and then I'll try to explain what's going on here, and then we'll do a couple of examples. So first, you need to fill in that we're going to draw a number line with the solution, its opposite and 0. There are 2 different kinds of dots that are used. We will either put an open circle if it is a less than or a greater than sign, and this is the less than sign, the first one here. This is a greater than sign. If the value has this line underneath it, that means that it is less than or equal to or greater than or equal to, and so we show that with a closed dot. And I'll explain kind of why that is here in a second. We will then shade the area to the right or left of the solution depending on the inequality symbol. And there's one unique thing that's going to happen on our very first example, that if the variable is on the right side, we will need to flip the inequality around so the variable is on the right, and it will flip the way the inequality is facing. I'll demonstrate this on the first example. So coming back to my example of x is greater than 16. In the case of needing a driver's license, you got to be over the age of 16. If I was going to graph this, I would draw a line, and then I would have 3 values on this line. not really too concerned with how you space these values out, as long as it's fairly equal. But remember, we're supposed to have the value of 0. We're supposed to have our solution, which is 16. And we are supposed to have the opposite, which is going to be the negative value. If we were given a negative value, then the opposite would be the positive value. So in this case, I have x is greater than, so I am going to use an open dot. And I often like to put these above the line. You can really kind of do it either way. We could put it on the line here too. We don't have to do both. I like to often put it above the line because then it doesn't get confusing with the line. And then I'm supposed to shade the area to the right or left of the solution depending on the inequality symbol. Well, in this case, x is greater than 16. So which way are values greater than 16? They would be to the right. So either I need to shade this line this way, and I'm going to use an arrow. And that's kind of why I feel like I don't like this method as well, because you really have to make the line dark. Up here, it really just takes a line and an arrow. So I don't care which way. Don't do both. But this means that when it's an open circle, that value is not included, which is maybe not the best example. For a driver's license, we would have a line underneath that, because as long as you are 16 years of age, you can get your driver's license, even the day you turn 16. So we would probably really want to have a closed dot for that one. And that's the other type. So either open dots or closed dots are used based on if you have just a greater than or less than sign, or if you have a greater than or equal to, or a less than and equal to sign. So let's move on to the next slide and start doing some examples. Maybe you're a little confused. Hopefully this will clear things up. When we solve these problems, we are going to go about them the same way. So the very first step, draw Mrs. Green line. And then I identify my variable as b. What's happening to b? It's being subtracted by 8. So we do the inverse operation, and so we are going to add 8 to both sides. Those will cancel over here, leaving me b. Include my inequality sign, which is a less than sign. And then we are going to add those two together. Probably should put my plus sign in there to get, sorry, let me fix that. To get a value of 18. Now, I told you this first example was going to be the one where the variable is on the right side. This does not happen quite as much. But if we think about this, I always think of a greater than or less than sign as kind of an alligator, and it points towards, so it's pointing towards the b. And if we would read this, this is a less than sign. So it's saying that 18 is less than b. Well, if we flip this around and we would write b on the left side of my problem, the alligator is going to follow that. And then we'd have 18. And you really need to do this, especially so it agrees with the graphing. I'll make that point here in just a second. So we're saying that 18 is less than b, which is also the same thing as b is greater than 18. Right? b is the bigger value. We know that because this sign is pointing towards that. The alligator is going after the bigger amount, and so it has to stay pointed after this. So b is greater than 18 is a better way of phrasing this. Anytime that variable is on the left side with inequalities, it's better. So now I need to graph this, so I draw my line. Sorry, that's not very straight. Maybe I can fix that real quick. It is always so hard to draw these lines really straight on here. I'm doing my best with it. Not perfect, but it'll do. Okay, we're going to have 0. We're going to have 18. And like I said before, it doesn't really matter too much that 18 is, I don't have to make a huge gap in between here. Space is limited. As long as I can see these values, I'm good with it. So then we now need to use an open dot, right? Because we have a greater than sign. And I'm not really going to look at this anymore because now I have my variable on that side. So we're going to put an open dot. Remember, I like to put mine above that. So that's what I'm going to kind of demonstrate. And then I know that b is greater than 18. So it's going to point off to the right, meaning any value that would be in this direction would also be true. 19, 20, 21. 100, 1,000. They're all greater than 18. All of those are true. So here is kind of why I insist on putting your variable on this side. Notice that I can make my greater than sign kind of look like an arrow, and now my arrows agree. A lot of students use that as their way to make sure the arrow is pointing in the right way, but if you leave the variable on the other side, look, this looks like our arrow is pointing to the left, and this one up here is pointing to the right. So I always favor doing this because that will always work. In this problem, because my variable is already on the left side, I know that when I draw a line at the end, you can see the arrow right there, my arrow is going to be pointing to the right. So hopefully that will kind of help you do that. Now I'm going to limit this video just to 15 minutes, so I may only have time for one more example here. But I'll try to work quickly so I can get that done. So we got a fraction, so we're going to draw Mrs. Green line. We're going to add 1/4 to both sides. That is going to allow these two things to cancel out over here. That leaves me with C is greater than or equal to, and then I still have to add 1/4 over here, and we're still going to have to keep in mind integers. Now these signs are opposite from one another, so I'm going to need to subtract. And if I subtract those two things, I do get negative 1 1/4. To see that more accurately, you're going to need to get common denominators, but I know I can subtract 1/2, and I can subtract 1/4 to get that. So when it comes time to graph it, here's 0, negative 1 1/4 would be over here. I could also write this as 5/4 if I wanted to, or 1.25, negative 1.25, and then my positive value would be 1 1/4 over here. And then, with that done, we're going to have a closed dot above the negative 1 1/4. Not a very good dot there. And we know that C is greater, so it's going to be pointing off this way. Just need to make it pretty obvious. And we are done with that one. Now there's two more examples. There's a solution of those. Maybe since time is limited here, I'll just let you look at these. And then I'm going to pause for a second. And since you'll have time to work those, and then I'm going to move on to the final slide, and we can just kind of stop there for a second and make sure your answers agree. So this is a good time right now to pause and go ahead and work these two problems. They're very, very similar. Notice that we do have the variable on the right side there in the first example here. So go ahead and work these out, and we'll come back to it. Okay, now that you've had some time to work that, the problem's out. Let's take a look and see what our solutions are. So I'm going to go ahead and just kind of fast forward here to the solutions. You can see it. We're down to the last 2 minutes of this video, so I wanted to be able to show you what's going on here. So again, having Mrs. Green line is helpful to see here. We're going to add 16 to both sides because that's the opposite of subtracting 16. Negative 21 plus 16 is negative 5. Negative 5 is less than A. Don't like the way that that's worded though, so we're going to write this differently as A is greater than negative 5. And kind of sorry, all the examples are pointing the same way, but this one also is going to be pointing right. Notice how it is an open dot starting at negative 5 and pointing off to the right. And for the final example here, we are dealing with decimals, which is a possibility too. So we're going to start by doing the opposite of subtracting 6.2. We identify the variable as r, so we got to start on this side of the problem. We're going to add 6.2 to both sides. Those would cancel. Again, Mrs. Green line is helpful to have here. Those cancel out. I'm left only with an r on this side is less than or equal to, and then when we add these two values together, they're both positive, so 10.2. And I like that we're ending with this one because it does remind you that we can have an arrow pointing to the left. R is less than or equal to 10.2, so I need a closed dot above 10.2, and it should point to the left. So that is all you are going to need to do for inequalities today. Hopefully you found this helpful. Tomorrow we move on to multiplying and dividing, and you'll also have to graph those. So thanks for watching, and best of luck on your homework.